Here we are, Unit 3, Lesson 5. We're going to look at a summary of the patterns you should have observed when you use technology to graph some quadratic functions. So the first pattern, when you're graphing a quadratic and you add or subtract a number at the end, it will move the parabola up if the number is positive, or down if the number is negative. So if you have your basic x squared graph with a vertex at 0, 0, a positive number added at the end will move that graph up, and a negative at the end will move that same shape down. The second rule for graphing that you should have noticed: what happens when you add or subtract a number inside the brackets? It's very important to make note of whether something is inside or outside of a bracket. If it's inside the bracket, it will move the shape to the left if it's positive, and to the right if it is negative. It is opposite to what you would think. A positive number goes towards the negatives, and a minus number goes towards the positives. So if we have our x squared shape, there's our x squared shape. A positive number will move it, that same shape, to the left, and a negative number will move that same shape to the right. So minus p goes to the right, and plus p goes to the left. And actually, we could do that on this graph. Plus q goes up, and minus q goes down. So there's the first two things. Up and down if you add or subtract outside the bracket, and left and right if you add or subtract inside the bracket, opposite what you would think. The third: if you multiply by a positive number, it changes the shape of a parabola. If a is greater than 1, the graph is stretched, makes it skinnier or steeper. If a is between 0 and 1, the graph is compressed and makes it wider. So if I have my basic x squared shape, and I multiply it by a number greater than 1, it will make my parabola skinnier. So when a is greater than 1. If I multiply it by a number between 0 and 1, it will make my parabola wider, compress it. So if a is bigger than 0 and less than 1, that would make it a fraction, and it makes your graph wider. And the last one, fourth one, negative x and negative a. Putting a negative number in front of the x squared changes the direction of opening to down. If a is positive, the parabola opens up. If a is negative, the parabola opens down. So if I have my positive x squared, negative x squared opens down. And if I have a number for a that is greater than 1, then it will make my parabola open down and be skinny. If I have a number that is a fraction and negative, then it makes my parabola wider and open down. So let's try to graph one of these together. So when we have an equation in this form, when you've got a number and a number inside the bracket and a number added or subtracted at the end, that is called the vertex form of a parabola. It's called a vertex form because The vertex can be read right from the equation. The numbers that are added and subtracted give us our vertex. Be sure that you always use the opposite sign with the P because it moves it opposite. So our summary, the P moves the parabola horizontally, left or right, opposite what you think. Adding goes towards the negatives, subtracting goes towards positives. The Q moves the parabola up and down. Positive Q moves it up and a negative Q moves it down. And A determines how steep it is. And if A is negative, then it opens down. If it's positive, it opens up. And if A is greater than 1, it makes the graph skinny. And if it's a fraction between 0 and 1, it makes the graph wider. So let's look at an example. There's my example. I'm going to show you two ways to graph it. One way is to use a series of graphs based on what each number does to the graph. So we're going to do a bit of a scale on here so our sketch is kind of accurate. It doesn't have to be super accurate. You don't need graph paper. But it just gives us a little bit of guidance. So when we sketch using a series of transformations, the first thing we do is draw the basic graph. So we're going to draw x squared. So x squared has a vertex at 0, 0, and then we go over 1, up 1 using our steps, and over 1, up 3 using our steps, and we join our points and get our x squared. Second thing we do, look at the numbers in our equation. I can see I have a +2 in the bracket. So basically the next thing I do is work left to right, showing what each number does to the graph. So we work left to right, moving the graph based on the number. So in my graph, I've got a +2 inside the bracket. The +2 moves it left or right opposite what you think. So because it's a +2, I will move the vertex to -2. So my vertex is now on -2. And then I can do my step pattern. Over 1, up 1, over 1, up 3, 3, and I can join up my points. And that's what the +2 does. And then I look at the next number. My -4 is outside of my bracket, so that means I shift the whole parabola down 4. So I work on the last one I did, my -2, and I move it down 4. So that puts it down here at -4, and then I can do my step pattern. Over 1, up 1, over 1, up 1, over 1, up 3, and I can join up my points. And that is my graph of x + 2 squared minus 4. So I can see that my vertex is at -2, -4. Right from the equation. Opposite the one in the bracket, exactly the same as the number at the end. Second way you can use to graph is you can come up with the vertex from the equation and use a table of values to show at least 3 points in total on the graph. So my equation was x + 2 squared minus 4. We just discussed the vertex in this equation is -2, -4. Opposite the P number, the same as the Q number. So I'll put a little bit of a scale on my graph. 1, 2, 4. And I'll put my vertex on. So my vertex is -2, -4. So because I know where my vertex is, I need to get 2 other points, so I have at least 3 points on my graph. So because I know where my vertex is, I'm going to choose 2 x numbers on either side of my vertex, and I'll create a table of values. So here's my table. My x, my vertex is at -2, -4. So -1 is just before -2, and -3 is just after -2. And then I'll calculate my table values. There's my equation. So I'm going to have -1 plus 2 squared minus 4. So that give me 1 minus 4 would be -3. And I'd have -3 plus 2 squared minus 4, which would give me -1. 1 minus 4 is -3. So I've got my 2 points, -1, -3, and -3, -3. And that's enough for me to sketch my parabola. So after I get my points, join to the vertex and make your parabola. So if you now know how to sketch graphs, feel free to shut off the video, go to your list of questions, and get started. If you would like to watch a couple more examples, I'm going to do a couple more examples and you can continue to watch. So I'm going to sketch these two. I'm going to do a series of transformations for both of these. So that means I'm going to start with my x squared, do a bit of a scale. So x squared, 0, 0, over 1 up 1, over 1 up 3, and there's x squared. So I look at my equation and the first number I see is that 2. And the 2 in front makes the parabola skinnier. So that means I would multiply my steps by 2. So instead of going up 1, 3, 5, all the odd numbers, I multiply them by 2. I'm going to go up 2, 6, 10. So my vertex is still in the same spot, but I go over 1 and up 2, twice as high. Then I go over 1 and up 6. 1, 2, 3, 4, 5, 6. 6. And I get a much skinnier parabola. So there's my 2x squared. So now I'm going to do my -3. It's inside the bracket, so I'm going to move it opposite what it looks like, and I'm going to move it, because it's minus, to the right 3. So I'm going to take my vertex to the right 3, and I'm going to move these points over 3. And I can graph my parabola. So there it is, skinnier by 2, and I moved it to the right 3. Last one is the +1. So now I've got to take the whole thing, and that moves it up 1. So my vertex is now up 1, and each of these points is up 1, and there we go. There's my final graph. Y equals 2, x minus 3 squared, plus 1. All right, next one. So if we start with our x squared, vertex is at 0, 0, Over 1, up 1, over 1, up 3, and there's x squared. Our first number is -1/2. The negative is going to flip it upside down, and the 0.5 is going to make the graph wider. So my vertex is at 0, 0, and my steps are now half as big as what they were. So instead of 1, 3, 5, I multiply by 0.5, so I'm going down 1/2, and then down 1.5, and then down 2.5. So I'm going over 1, down 1/2, over 1, down 1/2, over 1, down 1.5. That should give us enough to get the idea. There's our -0.5 x squared. Next number, -1, inside the bracket. So it moves it left to right, opposite what you think. So we shift the whole thing to the right. So my vertex is now at 1 and 0. And all my steps can move over 1 to the right. And there is my shift to the right. Last thing, I'm going to shift it up 5. So I'm going to be at 1, and my vertex will be at 5. And all my steps move up, or remember to go over 1, down 1/2, down 1/2, over 1, down 1.5, and there's my final parabola. Last one, we'll do the other way. So if we're going to do this the other way, then we're going to get our vertex. Our vertex is -4, opposite the p number, and -7. So put a little scale on here. One, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. There is my vertex. So now I need a little table. I want a couple of numbers that are right around my vertex. So right around my vertex, because it's at -4, -3 is right before it, and -5 is right after it. So we'll figure out our corresponding number. So we'd had 1 squared, -3, that would be -10. And that would be 1, -3, that would be -10. So we would have, I have to extend my page, 8, 9, 10. There we go. And there we go. And there's our graph. Y equals -3, x plus 4 squared, -7. Yes, you will need to graph both ways. Make sure you ask if you have any questions. Good luck with the questions in your homework.